Electricity, I mean, think about it. It's this invisible force that powers pretty much everything in our modern world, from the phone you're holding to the lights of an entire city. But to really get a handle on this power, we can't start with a power plant or a lightning strike. Nope. We have to go much, much smaller.
So, where does it all start? Where does the power that literally runs your world begin? Well, the answer isn't in some huge, complicated generator. It actually starts with the fundamental building block of our entire universe, the atom.
So, that's where we're going to begin our journey. To get what electricity is, we have to shrink ourselves down and take a trip into the wild world inside an atom.
You see, at its core, electricity isn't some kind of magic. It's actually pretty simple. It's just the movement of charged particles. And specifically, it's the flow of one tiny particle that changes absolutely everything, the electron.
So, every single atom is made of three main parts. You've got the positive protons and the neutral neutrons all packed together right in the center. But zipping around that core, well, those are the heroes of our story, the negatively charged electrons. And the crucial thing here is, they're the ones that are free to move around.
But what makes those electrons want to move in the first place? Well, that's where voltage comes in. The best way to think about it is like electrical pressure. It's the push that gets those electrons to start hopping from one atom to the next.
And once that voltage gets them going, that actual stream of electrons flowing through a material, that's what we call current. That flow, that movement, that's the electrical energy we actually harness to power everything.
Honestly, the best way to picture this whole thing is with water. Voltage is like the height of a hill. It creates the potential, the pressure. And the current? Well, that's the actual river of water flowing down that hill. Just like water, electrons naturally flow from a place of high potential to low potential. Now, not all materials treat this flow the same way. In some materials, which we call conductors, think of a copper wire, the electrons can move super easily. But in others, called insulators, like rubber, those electrons are locked down tight. And that simple difference is the key to how we control electricity and, use it safely. Okay, so we've got a handle on how a few electrons move. But how do you get trillions upon trillions of them moving together to power an entire city? Well, for that, we need to scale up from a tiny magnet to a massive metropolis.
The secret is in its really cool relationship between electricity and magnetism. And it's shockingly simple. All you need are these three things: a magnet, a coil of wire, and some kind of motion. When you move the magnet near the wire, or the wire near the magnet, it basically forces the electrons in that wire to start flowing. And just like that, you've created an electric current.
And that motion? It can come from practically anywhere. The spinning of a wind turbine, water rushing through a dam, steam from a power plant. They are all just different ways to create that motion. But if you look closely, the basic idea is always the same: magnet, coil, and motion. That's it. That's how we generate almost all of our world's power. So once that electricity is generated, we have to get it to our homes, which could be hundreds of miles away. To do that efficiently, power gets sent through the grid at incredibly high voltages. And why do we do that? Because higher voltage means less energy gets wasted and lost as heat along those long wires.
And when I say high voltage, I mean it's almost hard to imagine. These big transmission lines can carry up to 500,000 volts. That is a staggering amount of electrical pressure, and it's what's needed to push that electricity all the way across a country.
Of course, you can't just plug your phone into a 500,000 volt line. That would not end well. So that's where these transformers you see in neighborhoods come in. They use that same magic of electromagnetism to step down that intense voltage to much safer, more usable levels for all of our homes. And right here is the final step in that incredible journey. That massive voltage from the power lines gets reduced all the way down to that familiar, safe 120 volts that comes right out of your wall socket. So, we figured out how to harness and control electricity. But what happens when these exact same principles play out in the natural world on a massive, completely uncontrolled scale? Well, let's take a look at one of nature's most dramatic shows: lightning. Inside a big storm cloud, tiny ice particles are smashing into each other, acting like a giant static electricity generator. The bottom of the cloud gets super negatively charged, creating this huge voltage difference with the positively charged ground below. When that pressure, that voltage, gets too big, the air itself actually breaks down and becomes a conductor. And then, bam, a massive sudden flow of electrons. That's a lightning bolt. The amount of energy released in that single flash is just staggering. The air inside that little channel, the path the electrons take, is heated to an unbelievable temperature. We're talking 30,000 degrees Celsius.
Now, just to put that into perspective for you, that is 5 times hotter than the surface of the sun. It is an absolutely awesome and frankly terrifying demonstration of what happens when that flow of electrons is completely unleashed.
All right, let's bring all this back home. We've seen electricity inside the tiniest atom and lighting up the entire sky. But its story is also happening right now, inside your own body.
Now, this might be the most surprising fact of all. You are an electrical machine. I'm serious. Right this second, tiny electrical impulses are firing from your brain to your muscles, telling them what to do. Your heart is beating because of its own natural electrical pacemaker. Our biology, life itself, runs on electricity.
And because our bodies run on their own electricity, we have to be really careful with outside sources. The real danger isn't actually the voltage or the push, it's the current, the amount of electricity that actually flows through you. Get this, it takes less current to stop a human heart than it does to light up a tiny Christmas light. Just 100 milliamps can be fatal.
So, at the end of the day, just remember this. That tiny spark you get when you touch a doorknob, the vast network powering an entire continent, and the violent flash of a lightning bolt, they're all the exact same phenomenon. Every single one is, quite simply, the movement of electrons. We learn to understand and then harness the power of the electron, and doing that completely reshaped human civilization. It really makes you wonder, doesn't it? What other fundamental forces of nature are we just on the verge of understanding? And what's going to happen when we learn how to harness them next?